Okay, we are on the top of page 16 in the 6.8 notes. If you haven't already worked C and D, you should shut off your video right now and work those, because I know there are at least 4 problems maybe on your test that require foiling, so you need to make sure you're really good at it. So if you haven't already done them, shut your video off now and do those. Okay, so let's check what you've done. So F is 9, outer is negative 6i, inner is negative 6i, and from last we have a negative times a negative, so positive 4i squared. And like I said on the previous page, make sure you're careful with that I squared. A lot of students just write I there. So I times I is I squared. And then remember, we want to always write our little reminder up here so we don't forget. I squared equals negative 1. So every time you see that I squared in an answer, you need to replace it. Otherwise, it's considered not simplified. So this turns into, let's go ahead and combine these two. So 9 minus 12i, and then this is going to be 4 times negative 1, so that's going to turn into negative 4. So those two like terms, negative 12i, I squared, I replaced with negative 1, so that's negative 4. So in standard form, this answer will be 5 minus 12i. And like I said, you have to do that 3 or 4 times on your test, so you need to make sure you're really good at those. And we can do the same thing with fractions. So for F, 1/2 times 1/2. Remember, when we multiply fractions, it's the numerator times the numerator, 1. Denominator times the denominator, 2 times 2 is 4. So from F, we get 1/4. From I, a positive times a positive is plus, and then you do the same thing, just put that as 3 over 1, so 1 times 3 is 3, 2 times 1 is 2, so that'd be plus 3 halves I. Then from inner, we have a negative times a positive, so it'll be negative, and that one's going to be 3 times 1, 3, 1 times 2, 2i. And then from L, we get negative 9i squared. So what you should notice about this one is these are conjugates. Remember how we learned with conjugates, the middle terms will always cancel? We haven't done any other ones with conjugates. This is the first one, but they're identical except one's positive and one's negative. And what happens when we multiply conjugates, we learned in chapter 4, is the middle terms cancel, and 3 halves minus 3 halves is 0. This turns into negative 9 times negative 1. So this would be 1/4 plus 9, because a negative times a negative is positive, which is 9 1/4. Or you could write 37/4, whatever. If you did your calculator, it might give you one of those two. So either one would be correct. Okay, so that is multiplication. Now we're going to move to division, and you'll see every division problem has FOIL in it twice. So that's why I wanted to make sure that you're really good at foiling. So if you noticed, this is where division comes from. Whenever we multiply conjugates, not only do the i's, the middle terms cancel, but your final answer will have no i's in it. So we're going to use that concept. Remember when we were doing radicals and we learned to get rid of 2 radicals in the denominator, we multiply by the conjugate? Well, it's the exact same rules with I. So we have to get rid of the I in the denominator because we're never allowed to leave i's in the denominator. So how we do that is by multiplying by the conjugate. So what's the conjugate of 4 plus 7i? 4 minus 7i. And it's always a conjugate of the denominator, because the denominator is where you cannot leave i's. But if I multiply the denominator by 4 minus 7i, I have to multiply the numerator by 4 minus 7i as well. So in the numerator, I'm going to be foiling. But in the denominator, remember how we learned with radicals, if you multiply conjugates, you only have to do F and L a FOIL, first and last, because the middle terms cancel. So you really only have to do F and L. Only when it's conjugates, and that will only be in the denominator. So don't try to do it, everywhere you see foiling. It's only when you're multiplying conjugates, which means they're exactly the same, but one's plus, one's minus. So foiling the numerator, we get 12 minus 21i minus 8i and positive 14i squared. From the denominator, because they're conjugates, we just do f 16 and I negative 49i squared. So now we have to clean it up. So we need to replace this I squared with negative 1. We need to replace this I squared with negative 1. And then we need to combine like terms. So you can see down here on this next step, I've done that. 12 minus 21i minus 8i plus 14 times negative 1. 16 minus 49 times negative 1. So this turns to negative 14. And this one's going to turn to positive 49, right? Positive times a negative is negative. Down here, a negative times a negative is positive. So we have 12 minus 14, which gives us negative 2. Negative 21i minus 8i is negative 29i. And last we have in the denominator 16 plus 49. So then we add that and get 65. And this is the tricky thing about imaginary complex numbers, is we have to write it with a real part and an imaginary part. So after we get it simplified, then we have to write it as two separate fractions. Both of those fractions go over the 65. So it'd be negative 2 65ths minus 29 65ths I. And generally we write the I out to the side. So this is the best way to write it. So why do we have to do that again? Because all of our answers have to be in A plus BI form. So you have to have your real part up front, your imaginary part second with the I. When you leave it as a single fraction, it's not in that form. Remember, the last point of every problem is leaving your answers in, we call that standard form. Okay, let's practice on some here. And I did put one of these on the test. I think A is probably the closest. So let's go ahead and highlight A. Okay, so let's take a look at this. So we have 3 minus 2i over 1 plus 4i. So they're asking us to divide. Divide means get rid of the imaginary number in the denominator. So that's when the conjugates come in. And we say, oh, I can't leave an I down there, so I have to multiply by its conjugate. So the conjugate just means change that sign. So then it's 1 minus 4i. 1 minus 4i. And so remember, if they're not conjugates, we have to do the whole FOIL. So this is going to be a FOIL problem. Here they are conjugates, so we're only going to have to do F and L. Okay, so let's FOIL. So we get 3 minus 12i from I minus 2I. So 3 minus 12I minus 2I, and then positive 8I squared. And in the denominator, because they're conjugates, we only have to do F and L. So from F we get 1. From L we get negative 16I squared. And remember, we have two things to do. After we're done with this point, we have to combine like terms, and we have to replace all the I squares with negative 1. So this is another good place to make sure you write that so you don't forget. It happens in multiplication and division is when you usually see it. So this is going to have to be negative 1, and this is going to have to be negative 1. So we're not allowed to leave an I squared. And we'll do this one maybe on a separate sheet of paper, so we're going to use some of its space right now. So 3, combining these like terms, we get negative 14I. And this is going to be positive 8 times negative 1, which is negative 8, over, this is going to be 1 plus, because negative times a negative, positive 16. So then combining like terms up here, we get negative 5 minus 14I all over 17. And then you go, shoo, that was a long problem. But guess what? Not done. Because look what the directions say. We're not in A plus BI form yet. So we have to put this one over 17 and this one over 17. So the final answer will be negative 5/17 minus 14/17 I. Now it is in complex form, standard complex form. So now we can stop. And just an FYI, I don't know if this is true on the test or not, I can't remember, but if either one of these fractions can be simplified, like if this was 5/15, you would have to simplify it to 1/3. 17's prime, so I knew nothing simplified, but if they can be simplified separately, you do have to do that. So let's save B for later, since it's almost the same as A. We'll do it on a separate sheet of paper at the end. But let's go ahead and look at C. So C, I see this, but do you understand that that's going to produce an I? Square root of negative 9 would be 3I, right? Not negative 3I. The negative turns into an I. This is positive, so it'd be 4 plus 3I. And in the denominator, it'd be 2, whoops, getting off the paper there. It'd be 2 minus 2I. So after you do that initial step, it's the exact same problem we just did almost, right? So we look at this and we go, I need to get rid of that I, which means I need to multiply by the conjugate. So what is the conjugate of 2 minus 2I? 2 plus 2I. But whatever you do to the denominator, you must do the same thing to the numerator. So there's a couple things that you can never leave in a denominator. You can't leave 0 in a denominator. If 0's in the denominator, you have to write undefined. You can't leave radicals in a denominator. We learned how earlier in the chapter how to get rid of them. If there's 2 terms, you do the conjugate just like this. If there's 1 term, you make doubles or triples. And you can't leave i's in the denominator. So no zeros down here, no i's, no radicals in your final answer. So I think we'll pick up from here on the next video because I see we're running out of time.